Hi and welcome to a new video. Today we will talk a little bit more about the power mod on the GTX 1080 Ti. So like 5 or 6 months ago I got my first GTX 1080 Ti in the Founders Edition, and back in the days I made a tutorial how to power mod your card. Basically you have 3 shunt resistors that are measuring the power consumption of your card, and you can apply some liquid metal over the shunt resistor, therefore fool the power consumption measurement and therefore allow your card to draw more power. A few days ago I got an email from Chris, who is a viewer of my channel from the German content, and he also did the power mod according to my video. After around 5 or 6 months he noticed that, well, the system was not running anymore, and he tried to debug the system, and eventually he found out that some of his shunt resistors fell off. They came off the card. It must be some kind of chemical reaction between the liquid metal, which contains gallium, and the tin, which is used as soldering tin on the PCB of the video card. I saw that a lot of guys, especially on overclock.net, are using several methods to protect their shunt resistors or the tin on the video card from the chemical reaction. Usually I see that they're using either some kind of glue around the shunt resistor or nail polish or some kind of liquid insulation tape, and usually it seems to work to protect the tin from the chemical reaction. I'm also not really sure what kind of case is really necessary to force this chemical reaction, because I used this kind of power mod on a lot of my cards and I never had the case that one of the shunt resistors came off, but I saw some cases online in some forums where there were actually cases that the shunt resistors came off. So this is the card I used back in the days for my power mod tutorial, and that's also the card I'm using in my 24/7 system. So basically this card is running several hours per day. I'm also playing a lot of players on Battleground with this card. So it should be a quite good example to check the shunt resistors on my card, also to check power consumption under load. What I can tell you already is that, well, I'm using the card every single day and I didn't notice any kind of difference, no frame drops, nothing. I also checked the power consumption once in a while with GPU-C under load, and I didn't see any kind of changes. So I'm really curious if there's anything happening to my shunt resistors. So basically we will take off the cooler now and take some close-up pictures of the shunt resistors, see if there is any kind of difference. Afterwards I will put my card on my bench, and then we will do some superposition benchmark, because I still have the data from the benchmarks I took back in the days when I was doing the power mod testing. So we can essentially compare the data from today after 5 months to the data back when I was doing the tutorial first time. So I will be back in a bit when I took off the cooler, and then we will take some close-ups of the shunt resistors. So I just disassembled my card and took some close-up photos of the VRM area. And on this picture you can see the shunt resistors again. So on the top left you can see the shunt resistor that is responsible for the 6-pin connector. On the middle right you can see the shunt resistor that is connected to the 8-pin connector. And on the bottom right you can see another shunt resistor that is measuring the power consumption of the PCI Express slot. So I tried to compare the pictures with the pictures I took back like 5 months ago, and there are only very slight differences. So the top left shunt resistor seems to a little bit more matte. For some reason the middle one actually looks exactly the same as when I left the card the last time, and the one on the bottom right, the one for the PCI Express connector, looks a little bit even more matte than before. So it could be that the visuals of the liquid metal compound, in this case it's thermal Grizzly conductor node, that it changed a little bit. But taking a closer look at the soldered joints themselves, like the connection between the PCB and the shunt resistors, the soldered tin itself, I could not see anything. Like, it looked completely normal to me. I also used my finger and a small piece of plastic and tried to push away the shunt resistors from the side to see if they were kind of loose. Also tried to scratch a little bit with a piece of plastic on the solder tin itself to see if it can come off or something like this. But I could not find anything, so it still looked completely solid to me. I couldn't really see any issues to the solder itself. So then I put the card back on the test bench and did a superposition benchmark run from Unigen and compared the results to the data I did 5 months ago. What I found was that the boost clock was like 10 MHz lower than before, but 10 MHz is kind of measurement tolerance even, because the boost clock sometimes even changes. If you reboot, it could be that there is like 10 MHz difference. So in my eyes, nothing really changed. The power consumption still looks exactly the same. So no real issue on my card. So the real question is, what is causing those issues on some cards? And for most of the people, it looks to be fine. I would be very interested if you have any kind of data, if you have some experiences on this topic, if you did the liquid metal mod yourself, or maybe if you heard something from people on forums. I would be grateful if you put the sources into the comments. I would really like to read more about this topic, or if you have information yourself, feel free to shoot me an email on this topic. Anyway, I replied to Chris, the guy who sent me the email initially about this topic, and I offered to him to repair his card. So if he sends his card to me with the broken shunt resistors, I will solder them back and we can make a quick YouTube video about this, so you have kind of a tutorial in case this happens to you. It's actually quite easy to fix. All you need is a soldering iron and a little bit of time. It's very easy to fix, it should be no problem at all. Still, the big question is, why is this happening to some cards, and on most cards it looks to be fine. What I'm thinking is that it might be related to the type of liquid metal you use. I personally used Conductonaut. It could be that they're using a different compound from a different vendor. That might be an issue, but I'm really not sure what exactly is causing this. So if you have any experience about this, please put it in the comments. Otherwise, I hope you have a very nice weekend. Enjoy the rest of your Sunday. See you soon.